Hello, I'm Artur. I work as a senior React Native developer at CallStack in the R&D open source team. In today's episode of React Native AI Unpacked series, we'll cover our second runtime, React Native AI/MLC. MLC LLM is a universal engine for running on-device inference. You can check it out at llm.mlc.ai. With MLC LLM, you choose the model or models you want to use in your application, then build the app with MLC included and optimized specifically for those models so that inference is highly performant. This is enabled by advanced optimization techniques used by MLC, such as memory planning, operator fusion, hardware-specific optimizations, and library offloading. At the same time, the generated and optimized code is capable of running on a wide range of hardware and automatically leverages the capabilities available on each device. For example, most devices include GPUs that can execute parallel operations much faster than CPUs due to their architecture. MLC LLM can make use of these capabilities through multiple drivers, such as OpenCL or Vulkan, providing vendor-agnostic support. Even on low-end devices that lack of such GPU support, MLC can still accelerate computation by utilizing optimal CPU instruction sets, for example through operation vectorization or fused operations. MLC supports multiple platforms ranging from desktop OSs through iOS and Android, ending on web. Similarly, MLC supports many backends providing these accelerated computation capabilities, ranging from CUDA, the aforementioned OpenCL, and ending on niche ones for specific hardware. This approach allows for cross-platform hardware and vendor-agnostic deployment of a wide variety of downloaded or converted models. Unlike the built-in Apple models we covered earlier, these third-party models give you more flexibility in choosing which specific models you want to use. You can bring your own models or use popular open-source ones from the community, for instance by downloading them from Hugging Face. Finally, you can find the documentation under the link below. Our React Native AI/MLC package has first-class support for the AI SDK, which provides a unified API for everyone. This means you don't need to learn the specifics of our package, just use it as you already do in case of other libraries. What it also means is you get the same developer experience regardless of whether you're using Apple's built-in models or MLC's third-party models or whatever may come in the future. The API remains consistent, making it easy to switch between different runtimes based on your needs. Let's see how it looks in action. First, we'll start with our simple demo app. This is the demo app that's included with our repository. As you can see, it contains a few GUI elements. First, we have a model selection bar where you can browse through the models that are available. These models come pre-bundled with the library. This is how the declaration of the available models in our repository looks like. As you can see, the models are pulled from Hugging Face, for instance here. There's also a couple of parameters that are pre-filled here. You don't need to worry about them. And unless you want to pull in custom models, you can use the ones that are already pre-packaged by simply fetching them. So this is the API you can use to check what models are available at runtime, and then dynamically select from them. For instance, we display the GUI that allows you to pick your favorite one. This is also the only part of the code where you interface with our library's API. To get the models, to construct a language model, to instantiate it, to download it because each model needs to be downloaded from the internet, and finally, to prepare it. The preparation is actually a more complex operation that includes, for instance, the prefill phase, but you don't need to worry about that. In practice, you need to click Setup Model after selecting the desired one, and for the first time, on the first run, you will need to wait a while before it downloads, and after it downloads, or on any consecutive run, you will be able to just wait a few seconds before it becomes ready. As it becomes ready, the app offers three modes in which you can interact. So first is text generation. This is the typical use case when you click, you wait, and then you get the whole output of the LLM. You have streamText, so this works live, so you will see all the outputs as they come from the LLM, and then the LLM will finally, of course, stop generating. And finally, you have generate structured output, which is very similar to generateText, but you expect the model to output a JSON-like structure that will be parsed or it will throw a parse error, which also may happen since LLMs are non-deterministic, and especially on models that have fewer parameters, it may happen that sometimes they will not output a valid JSON. You will be able to, for instance, use it to interface with some kind of your implementation that will use the structured information output by the model to run your custom logic. So let's get started. First, we will try the generateText. So here we have a short prompt that says, "Hello, who are you? Please introduce yourself briefly." And let's try. This is the first inference, so it will also include the prefill phase. We need to wait a second. And finally, we have a pretty long response from llama 3 to 3 billion parameter. "Hello, I'm an AI assistant," etc. The next thing I will show you is generate structured output. So here, we will also generate some text, but this time we will want the LLM to actually present it in a JSON-like structure. And this time, if you take a look at the code, we will use the generateObject API. And here we will pass a schema. This is a ZOT schema that actually includes first the name and then the description. And we trust the LLM to actually output in the format that we desire this to be. For comparison with just generateText, it's pretty straightforward. With generateText, you would only point the model and the prompt. In case of generate structured output, the generateObject API, which comes, of course, from the AI SDK, you will also pass the schema, and that's it. You don't need to worry about anything else. Of course, except for the cases when the output won't be structured as you wish. As you can see, we are importing from the Versal AI SDK. So if you were already using it, you will notice that it's fairly easy to use our package underneath because you don't need to worry about any API differences. You can use the same syntax you would use in your other projects. And finally, we also have the stream feature, which is pretty cool because it allows you to see how the outputs come. I may even switch to a different prompt for the sake of this example. And here we will ask for the difference between AI and LLMs, which is often forgotten these times. So let's see how the stream will look like. And if we scroll down, we will see that we can see the buffer growing with the tokens that are actually being output by the LLM flowing in. And the API that we used for this is streamText. As you can see, no magic here either. We just pass the model, pass the prompt, and wait for the outputs. And that's it. As you can see, the integration is straightforward and the performance is really solid. If you have any questions or run into issues, please check out our documentation or create an issue on GitHub. And if you like the project, please go star it. We are here to help you build amazing AI-powered mobile apps.